We now have an understanding of the if statement structure and conditionals. We need to look at one more concept in order to build truly complex decision behaviors, and that is complex conditions. Namely, we need to look at the AND operator and the OR operator. These two operators allow us to combine many different decisions into a single decision. Here we have a script with two public integers in it, current level and invincible level. We also have a public boolean named isAlive, which is currently set to true. What we'd like to do is in the update determine if the player is no longer alive by setting the isAlive value to false, and also that the current level is less than the invincible level. We're going to assume there's a game mechanic in place where if the player is at or above the invincible level, even if we set isAlive to false, the player is not deactivated or destroyed. We can't really write individual if statements for these multiple decisions, because we need both of them to rely on each other. In fact, we need two things to happen simultaneously. That would be a complex decision that we need to turn into two simple decisions. To do so, we're going to write an if statement, and we're going to use the AND operator. Our first conditional would look like this: if isAlive equals false. Now you'll remember from a previous section, since isAlive is a boolean, we don't really need to test to see if it's false. We can instead shorten this and write it in a more brief way. We can simply say if not is alive, to say if currently we are not alive. Right now, since isAlive equals true, when we put the not in front of it, that becomes false, meaning this if statement will not run. Once isAlive becomes false, and we put the not in front of it, that becomes true, and this if statement will run. That might seem a little complex, but with time, it will become second nature. Now we could nest another if statement inside of it to build this complex decision. We could then write if current level is less than invincible level. And then inside here, we can call the setActive method of the game object and set it to false. While this works, it makes for some inefficient and hard to read code. Furthermore, this really only works when we're dealing specifically with two decisions. Often we're going to have more than two decisions. As a matter of fact, very shortly, we will have more than two decisions. So this structure is not one we can rely on and not one we should use. Instead, let's go ahead and write a more complex if statement using the AND operator. What we want to say is if not isAlive and, by typing two ampersands like that, and current level is less than invincible level. The result now is that we have a complex decision. If it's kind of hard to tell what order these happen in or how they're grouped, we can always group items using additional parentheses. Doing this is in no way necessary, but it sometimes can be useful to visually help distinguish between different decisions. Now let's go into Unity and see this in action. In Unity, we have a boy game object with this conditional script on it. I'm going to go ahead and press play. And we'll see that if I uncheck isAlive, the game object will be disabled. It was disabled because our current level was less than our invincible level and isAlive was set to false. Let's run it again. And this time, let's set our current level to be higher than our invincible level. Within our conditional, one side evaluates to true and the other side evaluates to false. Since we're using the AND operator, which requires both sides to be true, our code does not run. If I were to reduce the current level now, below our invincible level, we would see that the game object then gets deactivated. So now we can see that the AND operator requires both sides to be true. But what if we want to run some code if one side or the other side is true? In that instance, we're going to use the OR operator. To give an example where we can use some more complex objects than simple variables, let's imagine a situation where our game object is disabled if isAlive equals false, or if our platform is, say, PC. That might seem like a completely ridiculous situation, but it's still interesting to see if we can figure out how to make that decision. So let's modify our condition here. Right now we have if not is alive, which we still want, and then we're going to say or we are on a specific platform. We write or with two pipes, like that. For the or statement, we're going to say application.platform equals runtime platform Windows Editor. So what this statement is saying now is if the game object is set to not alive or is alive equals false, or if we happen to be on the Windows Editor, turn the game object off. Again, I understand that that's kind of a weird situation, but it's fun to see these more complex ways and pieces of the Unity game engine and what we can do with it. Back in Unity, I'm going to hit play, and we'll see that the boy is immediately deactivated. Even though is alive was not currently false, it was currently true, the boy still deactivated because we are in fact in the PC editor, or the Windows editor. With the or statement, only one side has to be true. Now let's come up with one more condition for this complex condition system. Let's say we will deactivate this game object if isAlive is false, or we are in the Windows editor and our current level is above the invincible level. Now you can see how we're starting to build really complex decisions that seem very kind of difficult to achieve by breaking them down into simple yes or no questions. The structure would look something like this. If not is alive, or application.platform equals runtime platform.windows editor. Finally, we will say and current level is greater than invincible level. So now we can see that we basically have one condition that's testing three separate true or false decisions that are all being combined with our true or false operators. Now it's important to know that we need to group these a specific way. We want to check if isAlive equals false versus the rest of that statement. We only need to check if current level is greater than invincible level if we happen to be in the Windows editor. So let's group those two together. We do that simply with parentheses. Now let's go back to Unity and see this in action. When I press play, you'll notice that the boy game object does not disappear immediately anymore. The reason is because current level is currently less than invincible level. There's two ways right now where I can get this boy to disappear. One is by setting current level above my invincible level, and the other is by unchecking isAlive. We basically have an AND statement determining two conditions, and then the result of that condition is being met with an OR statement and one more condition. So if I uncheck isAlive, the boy disappears. If I run this again and I set the current level greater than 10, the boy also disappears. Furthermore, if I were to change myself to a different platform, like OS X or Android, again, the boy would not disappear. Again, the boy would only disappear if isAlive became false. You can see that by stacking various decisions together with the AND and OR operators, we can build very robust, albeit sometimes completely ridiculous examples to get behaviors to function exactly as we want them to.